Hello everyone, myself Dr. Kavita Sarkar, Associate Professor, Department of Mathematics, Swami Vivekananda Institute of Science and Technology, Kolkata 145. Here is the syllabus of Mathematics 1B, paper code BSM 102 for first year BTech courses in Mechanical Engineering, Electrical and Electronics Engineering, Electronics and Communication Engineering, and Civil Engineering. There are 5 modules in this paper. Here I am discussing about module number 1, that is Integral Calculus. Topics are evolutes and involutes, evaluation of definite and improper integrals, beta and gamma functions and their properties, applications of definite integrals to evaluate surface areas and volumes of revolutions. From evolutes and involutes, I am going to discuss radius of curvature. Radius of curvature is denoted as rho, which is equals to 1 by kappa. Kappa is the curvature. What is curvature? The curvature is the measurement of a curve, how much it curves at a point. So here in the GIF, you see that the red circle is called the circle of curvature and the distance between the center and the point on the circumference is called the radius of curvature. Let us try to understand. X-axis, y-axis, and we have taken y equals to fx, a curve. Let us draw a tangent at a point P. PT is the tangent. PT makes angle psi with x-axis. A is the fixed point on the curve. S is the arc length between AP. So AP is S, angle PTX is psi. Now, curvature kappa is d psi ds. Rho is ds d psi, and we can derive as 1 plus y1 square power 3 by 2 divided by y2, where y1 is dy dx and y2 is d2y dx2. Okay, now the same formula for the curve y equals to fx, and if we take the Cartesian equation form as x equals to fy, then you just make the opposite of dy dx, take it as dx dy, and rest of the formula is same. This is the radius of curvature for polar equation r equals to f theta, where r1 is dr d theta and r2 is d2r d theta 2. And this is the radius of curvature for parametric equation x equals to ft, y equals to gt, where x dash is dx dt, y dash is dy dt, x double dash is d2x dt2 and y double dash is d2y dt2. Here is a question. Find the radius of curvature of the curve a square y square equals to a cube minus x cube at 0, 0. If we take this form as y equals to fx, then rho is 1 plus y1 square power 3 by 2 divided by y2. So we have to find y1 and y2. Now let us differentiate this equation with respect to x. Then a square 2y dy dx is 0 minus 3x square. So dy dx is minus 3x square divided by 2a square y. If we put x equals to 0 and y equals to 0 here, then we will have 0 by 0 form, which is the indeterminate form. Therefore, we cannot find the radius of curvature for this curve at the point 0, 0. Now let us change this equation in the form of x equals to fy. Then rho equals to 1 plus dx dy or x1 whole square power 3 by 2 divided by d2x dy2. So we have to find dx dy from this equation, differentiate it with respect to y, changing this order. So let us write first x cube, which is equals to a cube minus a square y square. Now differentiate it with respect to y. So 3x square dx dy equals to 0 minus a square 2y. So dx dy is minus 2a square y by 3x square. Put x equals to 0 and y equals to 0 here, then again we are getting 0 by 0 form, which is indeterminate. Therefore, we cannot find the radius of curvature for this curve also. If we change this point from 0, 0 to a0, then it may be possible to find. Let's see. We have got dy dx. So let us write dy dx. See that how much dy dx? Dy dx is minus 3x square by 2a square y. A square y. Now put x equals to a and y equals to 0. So x equals to a and y equals to 0, therefore minus 3a square by 0, which is indeterminate again. So by the form y equals to fx, we cannot find the radius of curvature. Then let us take dx dy. For the form x equals to fy, let's see how much dx dy. That is minus 2a square y by 3x square. Minus 2a square y by 3x square. Now let us substitute it y as 0 and this is 3a square. So dx dy is 0. Now let us find d2x dy2. So if we write 3x square dx dy equals to minus 2a square y and differentiate it with respect to y. Then we'll have 3x square d2x dy2 plus 6x dx dy whole square equals to minus 2a square. Now let us put dx dy as 0. Then we will have 3x square d2x dy2 as minus 2a square and d2x dy2 as minus 2a square by 3x square. If we put x as a and y as 0, there is no term y. So let us put x as a, then it will be a square and a square will be cancelled. So this is minus 2 by 3. Now let us substitute all the values in the formula. Rho equals to 1 plus dx dy whole square power 3 by 2 divided by d2x dy2. So this is 1 plus 0 divided by minus 2 by 3 and which is minus 3 by 2. Radius of curvature is minus 3 by 2 and curvature is minus 2 by 3. Here is a question. Find the radius of curvature and curvature of the curve root x plus root y equals to 1 by 4 at 1 by 4, 1 by 4. So you can use this formula for the curve y equals to fx form and get the result. Another question, find the radius of curvature and curvature of the curve y equals to e power x at where it cuts y-axis. This is the exponential function. So you know the exponential function. This is the point 0, 1. This is the function y equals to e power x. So at the point 0, 1, find the radius of curvature using this formula where dx dy you have to find y equals to e power x, take x equals to log y, take the form x equals to fy and using this formula find the radius of curvature. Question number 3, find the radius of curvature and curvature of the curve are equals to a 1 minus cos theta at r theta. Using this formula, find the radius of curvature. Question number 4, find the radius of curvature and curvature of the curve x equals to a into theta plus sin theta, y equals to a into 1 plus cos theta at theta equals to 0. So use this formula and find it. Books you may follow: Advanced Engineering Mathematics by Krzyk, Higher Engineering Mathematics by B.S. Grewal, Engineering Mathematics by Dashpal, Volume 1. Next lecture on Circle of Curvature.
For admission and course-related enquiry, please visit college website http://www.svist.org/